Yeah. Pressure exerted. If they given the pressure in the cylinder, they ask for the pressure exerted in the piston as well. So you just have to rearrange. No, because it's much of 2 or 3 forces acting together. If there is any additional cylinder or any additional force acting towards giving this pressure, then we have to consider the thing. Yes. Yes. Shall we move next question, sir? Question number 19. Shall I rub this? So for solving the pump problems, you have to know all these equations. This is flow, this is head, and this is power. If it is given pressure, P1 by P2 is equal to N1 by N2 square. This is for pressure. Don't confuse the pressure with power. Both are notations P. One is capital P and one is small p, but you cannot recognize that. This is law number 1, and this is law number 2. Q1 by Q. So you have to know this relation to solve any pump problems, that if data are given, you can solve from this. Okay. So we'll go to this problem. A minute. P1 is equal to. Pardon? Diameter. It's diameter. So in question, the P2, the new filtration system. A fan is served in an auditorium for a number of years with these characteristics. So the number of data are given. The building facilities manager plans to install more filters to improve the air quality. So a new filter system will increase the pressure by 1.5 in WG. So initially we have a pressure 2 in WG, and if it is increased 1.5 plus initial pressure 2 is equal to 3.5 in WG. So no problems. So to maintain, I'm sorry. I'm sorry. So to maintain existing flow, the new fan speed must be nearly. So they are asking for the N2. N2. From this formula, we have pressure and speed. So P1 by P2 is equal to N1 by N2 square. So pressure P1 is 2. Pardon? Oh, that's power. Don't get confused in that. 3.5 is equal to N1 square by N2 square. So how much it is? Or you can take square of this. So you will get N2 is equal to yes, sir. We need to add or multiply. No, we have to add this. Yes. Okay. So you have to memorize all this relationship to solve the pump problems. Yeah. I will get you in the screen. You can take the picture, I think. Of this. Pardon? Q, it's flow. Yeah. Q is flow, H is head, and P, the bottom P is power, and this is pressure. Don't get confused in this. Pressure it is cube, and for pressure, I mean power it is cube, and for pressure it is square. Yeah. This is P1 by this is power, and this is pressure. The same here. Actually, I am taking this square. No. Then this is n1 by if you yeah in yes no you have to multiply with yeah pardon yes you can try this with calculator as well. Yes. You should write 1/2. Yeah. Or else you can write it at square root better. Then multiply with n1, you will get the answer. Can we move next question? It is question number. This question is one of the important question which is asked repeatedly, and I have attended this question in while and shall I have this? Pardon? Yeah, it's a mercury, level of mercury. Hg is mercury, yes. Wg, yes. Hg is mercury actually. Pardon? Pressure, but Wg is similar to mercury pressure, but it's a level indicator. Yeah. So a motor pump draws water from a larger reservoir. It's drawing water from here. The water level in the reservoir remains constant. The pump required to move 300 GPM, the suction pump. So here there is two areas. One is discharge, and until this section is considered as suction. So the suction pipe is 4-inch, 40 black steel, and discharge pipe is 3-inch. So this is 4-inch pipe, and discharge pipe is so large reservoir contains water, temperature, and the pressure is given. So Q is equal to 300 GPM. Suction, it is 4-inch. And in the bottom of this table, they have given what is the ID and OD of this, right? Yeah. So here it is 4-inch. ID it is first 3-inch. Okay. 120 psi. Density of water 60.3 m per feet cube. Feet square per second. Pardon? Solid being here. So K entrance loss is equal to 0.5 and elbow loss 0.9. F is given. So they are asking for the line loss. So we know loss HF is equal to FLV square by 2GD. Correct? So here the L is equivalent length. So what are the parameters we know? F is known and LE we need to find. V it's not given. But we know Q is equal to AV. From here we can get Q by A. We know Q and area we can find, right? And G we know, D also we know. So, but since the loss of elbow and entrance loss is given, we have to consider that. Okay, we have to add that to the total friction loss. Pardon? Yes, total friction losses. Yes. So we have to add K entrance plus K elbow. Pardon? Yes, yes. No, actually it is plus. It's plus. Okay. So we can elaborate this. First, we will find what is V square. No, first we will find what is LE. We have to find the friction losses only in the section of the pipe because it's given including the entrance loss, the friction losses through the pipe. So we have to find the friction losses only in this section. So the total LE will be 20 feet plus, it's not 15 feet because if it is, the 15 feet is until the ground. This will trigger you to bit confusion. So we have to consider only 15 minus 1.5 feet. plus 20 feet is given plus 3 feet. Total how much? How much? No, in the top. In the top edge of the, yes. This 3 feet will not be considered. Because if the level varies, this loss will be calculated from the edge of this one. How much it is? How much? 20. 33.5. So LE we found. V Q by A. But all these parameters are in feet. We have to convert GPM to cubic feet per second. There you can use the conversion table. .668 cubic feet per second. Pardon? No, it is kinematic viscosity. Yes, it's. Pardon? Yeah. GP. Then you have to convert all this into meter. Because if you know the value G is equal to 9.81, you have to convert all these to metric units. Okay. But if you know the value of G, 32.2, it's 32.08 feet per second square. Then you can directly use this here instead. Since all these are in it's inches, right? But here density of water in feet cube and in the feet, right? Only the diameter we have to convert it into inch to feet. Then the Q to cubic feet per second. So it is 4 into 1 by 12. We are considering only the suction. So leave about the discharge. So it will be 0.018 into 33.5 into V square, it is Q by A, it is 0.668 by 5 by 4 into 4 by 12 square. It is, pardon? It is vapor pressure. Yeah, it's not the thing. Pardon? F we have here. It's feet. No, actually, no, all the parameters are being used for the solution. So first write down the formulas first and you have to check. Okay. Bye. Actually, it is 32.2. It's 32.2. 2G into D how much? 4/2. Even if you take 4.026 and 4, it is just a negligible one. It will not affect more on the answer. Yes, sir. Pardon? Oh, okay. Plus K entrance loss plus K elbow. So altogether you will get HF is equal to 2.84 feet. Zero point? It is cubic feet. 0.60, not horsepower. Q over A. No, actually it is V is equal to Q by A, but it is V square, right? Section on the elbow is visible, right? Yes. Why we consider D also? Pardon? D. Possible value of E, entrance loss. Pardon? Vapor pressure it is given, but we are not using that. Yes. Yes, clear. I have this. It's an ID of this suction pipe. You can use 4.026 because there is only negligible difference between this, so it will not affect much. Shall I have this? So read down this question. flow of water in a 10-inch schedule 40 pipe. So pipe is to be metered. The temperature of water is 100 °F and the static pressure up upstream of the water is 20 psig. So density of water is given, and assume the flow is a square edge device with a diameter ratio (0.5). When the flow rate is 1200 GPM, flow coefficient, what is the pressure drop? So they are asking, there is a pressure here. Let's say P1. There is a pressure drop here, delta P. So how much is that pressure? So first we'll write down what is given. Density is equal to 62 lbm per square feet. Flow rate Q is equal to 1200 GPM. And converting to cubic feet, 2.6736 cubic feet per second. And diameter D1 is equal to 10.02 inch. Converting to feet, 0.02 by 12 is equal to 0. And diameter ratio is given, D2 by D1 is equal to 0.5. So D2 is equal to 0.5 into 10.02 is equal to 5.01 inch by 12 is equal to 0.417 feet. So we need to find what is delta P. We know Bernoulli's equation. P1 by rho g plus P1 square by 2g plus Z1 is equal to P2 by rho g plus V2 square by 2g plus Z2. Since this is on same elevation, there is no height difference between the flow. The first section and second section is on the same line. So can I neglect Z1 is equal to Z2? Okay. So can write P1 minus P2 by rho g plus V1 square minus V2 square by 2g equal to 0. So taking out the common terms, pardon? I'm moving all these terms here. It's minus, right? V1 square minus V2 square. P1 minus P2. So taking out the common terms, P1 minus P2. Can I write it as delta P? Delta P by rho I am taking this outside. V2 minus V1 by 2 square. Correct. So delta P is equal to V2 square minus V1 square by 2 into density. So